Hello students, in last class we have seen about op-amp, its block diagram and pin configuration of op-amp. So, in the pin configuration we have seen that there are 8 pins, 2 pins are used for inverting non-inverting input, 2 pins are used for the plus VCC minus VE and pin number 6 is the output. So, offset null 2 pins again are there, that is pin number 1 and pin number 5. So, offset null pin. So, what is the use of offset null? So, there these 2 pins are actually for a special purpose. So, that we will discuss later on. Then there will be equivalent circuit of an op-amp. So, many times this question is there in your exam that draw the equivalent circuit of an op-amp and explain. So, in the equivalent circuit of op-amp we have to draw circuit like this. So, first draw the circuit like this of op-amp, then internal input resistance like this. So, this is input resistance Ri, then this is V2 and this is V1, that is inverting input and non-inverting input. So, V1 is your non-inverting input and V2 is inverting input, V2 is inverting input. So, it will be symbolized like this. Then there is, as we know in op-amp, op-amp is very high gain op-amp. So, here we have to draw output register and then this is VO, then here is gain A into VID. VID is what? VID is equal to V1 minus V2, difference voltage, and then this is grounded. So, this is the equivalent circuit of op-amp. So, this resistor is nothing but RO, that is output resistor. So, what happened here? A is what? Large signal voltage gain, large signal voltage gain. Then VID is, as I told you, V1 minus V2, difference voltage. V1 and V2, that is inverting voltage and non-inverting voltage. So, this is the equivalent circuit of op-amp. This one Ri, that means input resistance, RO means output resistance, and VD, that is difference voltage V1 minus VID, that means V1 minus V2. So, these 3 parameters are open loop parameters. Here VO can be written like this, VO is equal to AV into VD. So, AV is what? That is voltage gain. AV is the voltage gain, here we can write AV. So, AV is the voltage gain, VD is the difference voltage. So, VO is equal to AV into V1 minus V2. So, V1 and V2 is the voltage at non-inverting and inverting terminals of op-amp with respect to grid. Since both input terminals are allowed to be connected to independent potentials with respect to grid, the input side of op-amp is said to be double-ended type, but the op-amp is single-ended type. Op-amp responds only to differential input voltage VD. That means it produces output voltage which is infinity to difference between the input voltages and not to individual voltages. Hence, op-amp are also called as differential op-amps. This is the main point these are the important points regarding equivalent circuit of op-amp. Then next point we will see, that is ideal and practical characteristics of an op-amp. So, in characteristics of op-amp, if we get if we see the data sheet of op-amp, different parameters they have mentioned with different values. So, that parameters we have to study it first, and then we will see one data sheet, so that we will come to know what are the actual values of that parameters. So, next point here is characteristics of ideal op-amp. Characteristics of ideal op-amp. So, in the characteristics, first characteristics is input impedance, input resistance. So, suppose we denote it as a R in. So, input resistance ideally should be infinite. That means, practically it should be very high. Then output resistance RO should be ideally 0. Practically it should be very low. Then third parameter is voltage gain, that means AV, it should be infinite, it must be infinite. Practically it should be high, because it is high gain amplifier, so its gain should be high. Then bandwidth, bandwidth must be ideally infinite. Practically bandwidth should be high, practically bandwidth should be high. Then next parameter is offset voltage, which is very important parameter of op-amp, offset voltage. We will see what is the exact meaning of offset voltage after this point. So, offset voltage ideally it should be 0, ideally it should be 0, practically it should be low, very very low. Then next will be the output next will be CMRR. So, ideally it should be infinite, practically it should be high. Then next parameter is slew rate. Slew rate should be infinite ideally, and practically it should be high. So, these are the main parameters which are mentioned in the data sheet of every op-amp. So, here we will see one by one what are its practical values in the data sheet, what should be the practical values in data sheet, as well as offset voltage, CMRR and slew rate. So, next point is input resistance. So, input resistance Ri, it should be very very high, practically it should be high, ideally it should be infinity. So, input resistance value is in mega ohms. So, as two inputs we are applying, it is that resistance, input resistance we also called it as a differential input resistance. So, differential input resistance Ri for IC 741 is approximately 2 mega ohms practically, and ideally it should be infinite. Then output resistance, output of your op-amp should be with the output resistance of your op-amp should be up to 75 ohms. Practically it is 75 up to 75 ohms, and ideally it should be 0. Okay. Then next parameter is offset voltage. So, there are two types of offset voltage. So, offset voltage So, there are two types of offset voltages. First is input offset voltage and second is output offset voltage of op-amp. So, input offset voltage means what? It is the voltage that must be applied between the input terminals of op-amp to nullify the output. Ideally, your output of op-amp, when you are not applying any input, should be 0. Okay. But due to impractical situations like two components, like two transistors with same number, with same specifications we are using in op-amp, but practically what happened, they are not giving you same performance. So, because of that there is some voltage present at the output side. So, that voltage is nothing but the output offset voltage. Though there is no any input, there is some output voltage, that voltage will be in millivolts. So, that voltage is called as output offset voltage, and to nullify this output offset voltage, we have to apply some voltage in between these two terminals V1 and V2. So, that voltage is called as input offset voltage. Okay. So, offset voltage means it is offset, it comes because of some unwanted results, because of unwanted reasons. So, we are not applying any input, but we are getting output voltage in millivolts. Okay. So, that voltage is offset voltage, and while doing practicals this offset voltage should be 0. So, to minimize this voltage, we are applying some voltage in between these two terminals, that voltage is known as input offset voltage. So, there may be question in your exam, define input offset voltage, define output offset voltage. So, you can write like this, that output, first you have to write down output offset voltage. This is the output voltage obtained at the output pin of op-amp when no signal is applied at the input. Okay. And this is generally due to mismatch of transistors used in the op-amp. And input offset voltage is the voltage that must be applied between these two terminals of op-amp to nullify the output voltage. Okay. So, this voltage could be positive, input voltage could be positive or negative. Okay. So, therefore, your input offset voltage VIO can be written like this, and for IC 741 its value is approximately up to 6 millivolt. Okay. So, this is about offset voltage parameter. The next parameter is input bias current and input offset current. So, input bias current, what is input bias current? So, in op-amp when inputs are there like V1, V2, this is output, then input current flows through this inverting terminal and non-inverting terminal. So, that current is known as IB, that means bias current. So, these two current IB1 and IB2. These are the bias currents. So, there are again two parts for this bias current. First is the input bias current and second is output bias current. Sorry. Input bias current and here input offset current, not output, input offset current. So, input bias current, it is the average of input currents flowing into the inverting and non-inverting terminals of op-amp with the output at 0 volts, with the output at 0 volts. This is very important word. So, input bias current can be written like this: IB is equal to IB 1 plus IB 2 divided by 2. It is the average of input currents flowing into inverting and non-inverting terminal. And what is offset current? Offset current is, can be written like this: IO is equal to IB1 minus IB2. So, what is this then? It is the algebraic difference between the input currents flowing through inverting and non-inverting terminal of op-amp. So, IIO is the input offset current and IB is the input bias current. Input bias current is the average of two currents and input offset current is the difference of the two currents. So, what are the practical values? Input bias current for IC 741 can be up to 50 nanoamperes, and here offset current can be up to 20 to 60 nanoamperes. So, practically these values are there. Ideally it should be 0, it should be very low. So, this is another parameter. So, that means we have seen main parameters of op-amp. First is input resistance, then output resistance, then input offset voltage, output offset voltage, then we have seen input bias current and input offset current. So, there may be question in your exams: define input bias current, input offset current, then input offset voltage and output offset voltage. This can be for 8 marks. So, this is very important point. So, these are the very important definitions. Then next point, next parameter is CMRR, and yes, next parameter is slew rate. It is the maximum rate of change of output voltage per unit time. So, it is actually defined as time rate of change of closed loop amplifiers output voltage under large signal conditions. So, its value practically its value can be in 0.5 volts per microsecond. So, this microsecond is very important. Many times student by mistaken write like this: 0.5 microvolts per second. So, this is wrong. So, right is 0.5 volts per microsecond. It is the maximum rate of change of output voltage per unit time. So, we can write it like this: Vo max by dt. So, this is nothing but the slew rate, maximum rate of change of output voltage with respect to time. So, its value, as I told you, 0.5 volts per microsecond. Its value should be high for high frequency applications, that is, output should change as soon as input changes. So, slew rate. In short, we can understand it by output should change as soon as input changes. So, it is the maximum frequency for which amplifier produces undistorted output. So, from this we can calculate the maximum frequency at which you will get undistorted output. So, also there is one formula for slew rate. S is equal to 2 pi Fm Vm. Fm is what? It is the maximum frequency and Vm is maximum voltage. So, slew rate, this formula is very much important for calculation of slew rate and solving sums on the slew rate problems. So, next parameter is CMR. This parameter all of you know that we have learned in the second year. So, in short I will tell you common mode rejection ratio. So, common mode rejection ratio is nothing but the ratio of differential voltage to common mode voltage. So, AD by AC, and practically its value is up to 90 dB. So, it will reduce the noise. The next parameter is open loop gain of op-amp. Open loop gain of op-amp. So, gain is nothing but A equal to output voltage by input voltage. In op-amp, in open loop op-amp, open loop means what? There is no feedback, and closed loop means there is feedback to the op-amp. So, without feedback your op-amp is having a very high gain. Normally it can be 2 into 10 raised to 5 for 741 IC 741. So, this is very high gain, which is nothing but the ratio of output voltage upon input voltage, input differential voltage. V in is nothing but the V1 minus V2. Okay. So, this is the open loop gain parameter. Then next will be the SVRR, CMRR, then open loop gain, then SVRR. SVRR is the supply voltage rejection ratio. So, if the power supply voltage is suppose V plus and V minus, suppose drift from their nominal value, the output voltage of op-amp changes. We are applying here plus VCC and minus VEE. It is nothing but the plus V and minus V. So, if these values changes or a drift from its nominal value, then output voltage will change. So, ratio of this change is nothing but the SVRR, supply voltage rejection ratio. So, it is the ratio of, it is also known as PSRR, power supply rejection ratio. So, it can be written as change in VIO divided by change in V. So, it is the change in an op-amp input offset voltage VIO caused by variation in supply voltage changes. So, it is expressed in dB or microvolt per volts, and practically its value can be up to 150 microvolts per volts. So, lower the value of PSRR, better will be the performance of op-amp and regulation of supply. Today we have seen all the parameters of op-amp. So, there may be a question for 10 marks in your exam. Define these parameters and write down its practical and ideal values. So, from this lecture we will come to know that which parameters are there and what are its values practically as well as ideally. So, see you for next lecture. Thank you.